This is the model answer video, Key Assessment 3, Paper 3, Lower 6 Core Concepts. Hopefully you've watched the Help Me video with a few teasers and trying to get you thinking in the right direction. This is question 1. Glucose concentration is measured using a number of tests. You know one that's using Benedict's reagent and heat, and it gives a brick red precipitate in the solution. Possibly they've done that here, and with increasing concentrations of glucose you get more absorbance. Absorbance is when they have a sample and they are shining a light through the sample and they are measuring how much light gets through. The absorbance is how much gets absorbed, so which doesn't get through, in other words. So they're seeing how much this solution doesn't let the light through. And on this graph here we can see at the origin, if we've got no glucose, imagine the Benedict's with no glucose, so there's no precipitate, then none of the light gets absorbed. It all passes or transmits right through. At high glucose, then we're going to get less light go through, so the absorbed light is higher. Glucose does not appear in the urine until blood glucose of 0.18, and we've tested a urine sample and the absorbance was 0.17. On this graph here, the absorbance is on the left, 0.17. Well, I've drawn that line there, so that's from 0.17 arbitrary units, and when we go down there, that gives us 0.75 milligrams per cm cubed. So that's a blood. That's how much it would. That's the actual concentration. This should be none if the diabetic is a non-diabetic, and this reading is 0.75. So we've got glucose in our urine, which shouldn't happen. So glucose does not appear in the urine. So we can say they have diabetes. And that's going to give you a mark. And then the second mark is the reasoning behind it. Reading is 0.75 milligrams per cm cubed in the urine. It should be 0 for a non-diabetic. And it does say blood glucose concentration 0.18. Well, we're not comparing like with like, so you could say, well, this 0.75 is above 0.18. But we're not really comparing like with like, although they accept that in the mark scheme. Why is it not possible to use a standard curve for glucose determination in the whole blood sample? Well, you can imagine here, this is our whole blood sample, and we're shining a light in. The light's going to get absorbed by cells, platelets. So, and this is a red colour, so it's going to interfere with our light passage through here. So we couldn't really do this. There's too many obstructions. So blood is red. E.g., red blood cells. So light cannot pass through. And that'll do us for a mark there. And now we've got a question on immobilized enzymes and biosensors, and 2 advantages of really using immobilized enzymes. Pretty straightforward. With enzymes, well, this glucose oxidase, well, as the name suggests, it's going to be catalyzing the reaction of glucose, and it's glucose only, so the result that we get will be specific for glucose. It won't give a reading, for anything else, and it's glucose that we're testing for. We use enzymes as well because they will give a reading even if there's a very low concentration. So they are good at detecting very low concentrations. And then that'll do for 2 marks. That's fine, but we'll give all the possible answers. So there's a couple of marks, saying, well, why immobilized? Why is immobilized good? Well, the enzyme is more stable if it's immobilized, and that indeed will get you a mark. So the enzyme is more stable, which will give an accurate, reading. An example of this would be, thinking about temperature. The enzyme will be more stable over a temperature range. In reality, you're not going to really, use very low or very high temperatures. But we'll accept that as a mark. If it works at different temperatures, as an example of that. Yeah, just destroy my light. It's fallen off the shelf. Dear me. Not my highlight. And we've got 2 monosaccharides. Describe the difference between these monosaccharides. We have got, as I showed you in the Help Me video, we've highlighted the difference. We've got OH there and H there, but we need to be a bit better than just saying one's got an OH, one's got a H. We need to identify which carbon they're on. So 1, 2, 3, 4, 5, 6. So this is carbon 4 for each one. So on carbon 4, the glucose has got H above the ring and the OH below, and the galactose has got OH above the ring and H below, or the same thing the other way around. So glucose, H above ring, OH below ring. Galactose, OH above, H below. So we're showing that we know how to name and number these structures. What would be the products of a condensation reaction? Well, in a condensation reaction we are removing water. So water, and the name of the disaccharide, which is glucose and galactose, which is just lactose. So I got to the end of that without electrocuting myself with a falling light, so all's good in the world.